Question number 2, define free falling body. Alright. So let's say you have object released from the rest, so meaning the objects start moving downwards in the straight line with the gravitational g accelerates 9.81 meter per second square. So if you define the free body diagram, so first you must consider the direction to downward influenced by the gravitation acceleration g 9.81, and this is vertical, right, meaning direction to the vertical to the negative y. This is how you can describe a free body diagram. Continue to the question number B. Figure to show the displacement time graph, y displacement, the time t of particle. So number 1, that means the total distance traveled by the particle. So meaning what is the total distance? So the distance traveled. Let's look at the graph here. First, we have from the initial position 0 distance, and the next continue moving, so displacement is 8, right? So 8 meter, and the next is travel from B to C here. So the distance here, so if you look at, this is 8 and this is 4, so meaning here we have a 8 and plus 2 meter and plus 2, so here we have a 12 meter. And the next from 4, from C to D here, the distance here is a 4, sorry, this is C here, so we have a 4 and this is 2. So here from C to D here we have this is 4 and this is 2, so this is plus 6. So here we have 18, 20, 26 meter. This is number 1. Continue to the number 2. Which segment of the journey does the particle move the slowest? So the segment of the journey is particles move the slowest, you can refer to the velocity, right? So for velocity graph, displacement or distance versus t, you can calculate velocity from the gradient of the graph s divided by t. So if you calculate the gradient here, calculate the gradient here, the gradient here, so if you find the minimum velocity, meaning we have a slowest. So which part? So if you calculate they say this is the AB from BC and the CD, so the gradient of the part from A to P is a minimum or the smallest value of the V. So meaning here the segment of the journey does the particle move the slowest from A to B. Alright. Continue to the number 3. How does time of the particle returns to its starting point? Starting point here, we start from at the point A here, and if you look at the graph here, at the point here, meaning the object, okay, from A to B, right, from A to P, right, and if you look at the position here, so meaning here we have 2 time of the objects or particle return to the starting point. So we have the first and the second time, okay, 2 times objects particle return to the starting point here. So and the displacement of y is equal to 0, right? Okay, so number C, a driver traveling at 100 km per hour on the straight road suddenly see the car 32 meters ahead. Immediately apply to the brakes, braking deceleration 6 meters per second square, calculate. So if you draw the, let's say this is the situation, this is the car, right, with the velocity, and this is a distance here between the, let's say this is the car, right, this looks like the car, so we have a car here, right. I'm not sure this is okay, so you can see, you can distance here from the car that is moving with the u is 100 km per hour, and the distance here is 32 meter, right, from the car and the car, and start accelerate, right, accelerate 6 meter per second, meaning acceleration is 6 meter per second, because deceleration we have a negative. So now what the speed when the car hit the car, right? So here you can use the equation of v square is equal to u square plus 2as, because the car moving with the velocity u 100 km per hour. So make sure if you use the value 100 here, you must convert to the SI unit here, right? SI units to meter per second, right? And as the acceleration here is given by the value of, can use the deceleration must use a negative, right? And the displacement, the distance between car and the cow is 32 meters. So you can find the value of the final velocity or speed when the car hit the cow is okay, use the calculator here, so make sure you must convert the 100 km per hour to the meter per second. So we have 19.7 meter per second, right? This is number one. Number two, the minimum that he should apply the brake so that he doesn't not hit the car. Okay, so here to answer number two here, because the minimum time here, so you can, because this is we can have the acceleration here. So I think the question number two, we have the problems to find the answer. So we will discuss in the class for the question number two, right? Continue to number D. Archer standing a cliff 45 meter high, shoot an arrow at angle 30 degree above horizontal speed of 80 meter per second. So calculate duration of the arrow in air. So the time t. To calculate the time t here, you can use the equations. S is equal to ut minus half gt square. And if you draw the situation given by the question here, so let's say we have this is Archer with the arrow launching with the angle theta is 30 degree, so this is 30 degree theta, this direction of, oh, sorry, so, yeah, okay. height here is a 48 meter, and we have the this is arrow with the speed 18 meter per second, and the angle here theta is 30 degree. So now to find the time of flight here, we consider the horizontal motion for the y, or this is sy, this is uy here. So uy here from the high to the this is basic ground surface, right? Because the direction arrow to upward and the downward here, this is upward to positive, negative, so here is equal to 0. Just consider the 48 direction here is 48 is because to downward we have a negative 48 meter, so this is negative 48 meter. And we have initial u here, you resolve to the uy, so this is a uy, so we have a uy 18, theta here is 13 times t minus half, g is 9.81, and this is t square, right? So now you can use the equation or find the value of the t. The final value of the t is 9.2 seconds. And this is number 1. And number 2, horizontal range. So to calculate the horizontal range here, so meaning here, if I draw the path of the motion here, so the arrow moving upward and start moving downward, and this is a final position here, so this is a range r. So how to calculate the range r? So you can use the range is equal to uxt. So ux is always constant, resolve to the, this is a ux resolve 80 meter per second to the ux, so 18 cos 30 time of flight or duration arrow. This is from answer number 1, 9.2. So the final answer is 637.4 meter.